Let's take a look at practice question set number 7 that we had for homework last night. 3 questions that we're going to do in preparation for our quiz tomorrow that's on the same material. That's intro to electricity stuff. Question number 1 starts off with this big page of information here. We got a Van de Graaff generator. We got to be careful with this, actually. If you know anything about a Van de Graaff generator, which there's a good chance you don't, but if you did, you'd know that the Van de Graaff generator usually has a negatively charged dome. We got to be careful because in this case, it's actually positively charged. So we want to maybe draw attention to that, the fact that it's a positively charged dome so that we don't end up forgetting that and getting a wrong answer as a result of that. That's a nasty little trick. When they put this on an exam, I wasn't happy about that. That was a nasty little trick because we almost always see it as a negative dome, and then they just make it positive just to see if you're reading well, not to see if you know what you're doing, but to see if you're reading the question well. And I don't know, I thought that was kind of cheap. But anyways, they did it, so we got to be able to deal with it. It says the metal sphere, which hangs on a thread, touches the dome of the generator and is then repelled. The mass of the metal sphere is 2.0 times 10 to the negative 5. So here's what's happening. We've got a positively charged dome, and then you've got this neutral thing right here that has no charge. They're going to attract each other, right? Because positive attracts neutral. And we know that positive attracts neutral because of that temporary separation of charge. Now, what happens when they touch each other? They're both metals, they're both conductors, so they're going to want to balance out. They probably won't balance out because the Van de Graaff generator has a bigger dome. It's probably going to be able to hold more charge than this little neutral metal sphere. But the bottom line is they're both going to become positive. If one's plus 10 and one's 0, they're going to want to balance out to be plus 5 and plus 5. It may be plus 8 and plus 2, or maybe plus 7 and plus 3. The total charge is going to stay the same, but since some electrons do transfer, they are both going to become positively charged. All right, so when they both become positively charged, then what's going to happen to them?
It's going to start trying to get away from
Yeah.
the object.
Yeah, they're going to repel each other, right? So they're attracted, they touch, and then they repel. This happens much better with conductors than it does with insulators, because with insulators, you may get that force of attraction taking place, but when they touch each other, if you have two insulators, you're not going to get nearly as much charge transfer going on, not nearly as much conduction going on there, and therefore, they're probably not going to repel each other, at least not for a while. All right, let's see what we got here as we scroll down. It tells me that this metal sphere is in equilibrium. Equilibrium means, what's a two-word synonym for equilibrium? Yeah, 2 words. Balanced forces. Balanced forces. Okay, equilibrium means, generally it means balance, but we're talking about equilibrium in physics, we mean balanced forces. So that's what we got here, balanced forces. We know that we have an electric force pushing this way because the electric force is pushing that metal sphere away from the Van de Graaff. We also know that we have a force of tension in the string this way, and we have gravity acting this way. We know that these 3 forces end up balancing each other out. Okay, the net force is 0, otherwise this thing wouldn't just be suspended there, it would still be moving. All right, let's see what the question says. It says, when it touches the generator, the metal sphere becomes, all right, what does it become? You got a neutral metal sphere, you get a positive dome of a generator. They're going to touch each other and they're both going to become positive. Right. So the answer is going to either be C or D. And that happens as a result of a transfer of, this part's easy. Can we? Good. It's electrons because it's never going to be the protons that transfer, right? It's always going to be the electrons. So the answer for that one is C.
I almost chose A because I thought that the generator was the same as that. I was like, oh,
yeah.
Wait a minute, that's wrong.
That would be a really common mistake, actually. A really common mistake to choose A because a lot of times we assume that Van de Graaff generator is negatively charged. All right, let's take a look at number 12 now. 3 identical conducting spheres, 1, 2, and 3, have initial charges of plus 4 microcoulombs, negative 2 microcoulombs, and negative 4 microcoulombs. We're touching these things together. We want to see what the charges end up becoming. The microcoulombs here isn't particularly important in this question because since we're just averaging things together, it doesn't really matter what units we're in. We don't need to convert to coulombs. But later on today, as we learn about Coulomb's law and solve problems involving Coulomb's law, bigger problems, we want to make sure that we're going to be in coulombs. So as a matter of habit, I'm going to circle that microcoulombs to draw attention to it. I certainly want to circle the negatives because when I'm touching two things together, it's important whether they're positive or negative. I got to know that. Go ahead. Question? No? All right. So we touch these things together in 3 steps. We have 3 charges here. I'm going to call them 1, 2, and 3. Create a little chart here to determine what those charges become. These start off as 4, -2, and -4. And I touch 1 and 2 together. 1 and 2 touch together. Now, if I add up the total charge of 1 and 2, 4 plus -2, it gives me 2. So what's the charge going to become down here? 2 and 2? Is that right?
1.
It's going to become 1. Right? If I have a total charge of 2 circled in green, then I have to have a total charge down here of 2. So what I'm going to really do is not just add them up, I'm going to add them up and divide by 2. 4 plus -2 is 2, divided by 2 is 1. And this one's still -4 because nothing's happened to that one yet. Now 2 and 3 are going to touch each other. 1 and -4 are -3. Divide that by 2 and it becomes -1.5 and -1.5. This one stays 1 because nothing happened to it in that stage. Now 1 and 3 are going to touch each other. 1 and -1.5 gives me -0.5. Divide that by 2, it gives me -0.25. And we're still dealing in microcoulombs, right? This one remains -1.5 because nothing's happened to it in that state. What's the final charge on sphere 1? Well, it's going to be -0.25 microcoulombs. So the answer for that one is also C. And I think we had one more question. Yeah. The number of excess electrons on a ball that has a charge of -3.6 times 10 to the -17. This is that orange question, right? You go down to Save on Foods and you buy oranges, and you know that the mass of one orange is 200 grams, and you get a bag of oranges that's 600 grams. It's 3 oranges, right? The total mass divided by the mass of one orange. Remember, to find the number of excess electrons, it's going to be the total charge divided by the charge of one electron. Total charge is -3.6 times 10 to the -17. The charge of 1 is -1.6 times 10 to the -19. And we do the math there, it works out to be 225 electrons. Now, we do want it in scientific notation. Okay, watch for that. That's going to be 2.25 times 10 to the 2. Now, how do they want it expressed? Well, if they want it expressed A, B, C, D, which they do in this case, my answer would be 2252. Now, what's another common way of asking it to be expressed?
Just say, give me A, and that's it. A,
Yeah, or usually it would say B times 10 to the W. And the value of B there wouldn't be 2. Okay, to a 3-digit answer, it would be 2.52. Now, because this one is actually just 225, they could just say, what's the answer? Right? What's the answer? And not put it in scientific notation. In that case, it would be 225 and would leave the last box blank. Remember, if we're leaving a box blank, you guys remember that, right? You always leave the last one blank. You see that in physics and math and chemistry. I don't know about biology. Do you have numeric response in biology? Yes? Do you ever have to leave a box blank? Yeah, it's always, you always start on the left-hand side, right? All right, questions on that?